Okay, for number example 22, we're going to figure out what delta H is for this, and we're going to answer this question. Okay, so we are going to say then 1 times CO gas plus 1 times PB solid, products first, minus 1 times PBO solid plus 1 times carbon solid. Remember, you have to have this, then fill in your numbers and get an answer. If you don't have this and the numbers filled in off the sheet, I'm not giving you credit for the work. So you got to have this part and then the numbers filled in, and then you can just do the math and come up with your final answer. So we're looking for 1 carbon monoxide gas. Okay, so we're looking for CO gas, carbon monoxide, negative 110.5. So this is going to be negative 110.5 plus, now lead is a solid in standard state, so I can say, oops, plus 1 times 0. Now, if you don't want to remember that, you can always look up lead. So we're going to look up lead in L's. Let's see where the L's are in here. There they are, lead, so we can see that it's that. Okay, but we would have known that was 0 for delta H if it's elemental in standard state, which it was, but you can look it up if you don't want to have to memorize that. Minus 1 times PBO solid. So PBO solid, PBO2 solid, I believe it was, yeah, PBO2 solid is negative 277. That's PBO solid, so let me go back high. PBO solid would be a negative 219. Okay, negative 219. So 1 times negative 219, was that 219? 219.0, yeah, 219.0. Okay, so 219.0 plus carbon in its standard state would be 0 because carbon on the periodic table is a solid. Okay, so then you're going to go ahead and do that math. When you get done, you should get the positive 108.5. Okay, so we're going to take 110.5 negative minus, I can't read my handwriting, 219.0 negative equals positive 108.5. So we do get positive for this, positive 108.5. Okay, so then the question says, what is delta H for the formation of 23? Remember, this is when I get 1 mole of each of these, or however many moles I have here, right? So we're going to take, now it says formation, because you always have to think about, do I keep the sign the same, or do I change the sign and make it the opposite sign? If it's positive, do I keep it positive, or do I make it negative? Well, this says the formation of PO. Does this reaction up here with delta H being positive, that we just calculated, does it show the formation of lead to oxide? It does not, so I have to reverse the reaction. I have to make the reaction go this way to form a PBO, so that means it's going to end up being a negative 108.5, because I have to reverse the reaction to form PBO. If this said reaction of this many grams of PBO, then it would keep it positive. But it says formation, and this does not show PBO being formed. So in order to form PBO, I have to go the opposite direction, which means I flip the sign from positive to negative in this case. So we're going to start with 23.1 grams of PBO. We're going to use a periodic table and look up the value of lead iodide. Let me try that again. My goodness. Lead to oxide. So lead to oxide, I already looked it up just for time. I'm going to grab it. 223.2. So I calculate 1 PB and 1 O, 223.2 grams per every 1 mole of PBO. This is a 2 down here. And then from the balanced equation, I know 1 mole of PBO equals positive 108.5, rather not positive, negative, because I had to reverse it, okay? Negative 108.5 kilojoules. Why negative? Because remember, formation means we have to reverse the reaction. Okay, so then when we do that, we should get the negative 1123. So let's try that. 23.10 times 108.5 negative, divide by 223.2, and I get negative 1123 after rounding. So we do get our answer in red, negative 1123 kilojoules. So be sure you're careful about what it's asking for, and does what it's asking for, the descriptor word in there, does it describe what it shows? If not, you got to reverse it. And if you reverse it, you change the sign, in this case from positive negative, or if this was negative, it'd go from negative to positive.